a condition that affects 3% of all children in the world, and with more than 3 million new cases every year. If left untreated, it can lead to deformity and even cause serious heart and lung damage. In most cases, this disease is treated on time, but when it's not, the consequences over time are unbearable. We are talking about scoliosis. Some of the most popular methods for detecting and monitoring scoliosis are X-rays, spinal radiographs, MRIs, and CT scans. But these methods expose the patient to unhealthy amounts of radiation. Here's where the COBB angle comes up. One of the most famous tests for scoliosis is the Adam Forward Bending Test, which offers an easy way to check for scoliosis. How does this work? Scoliosis can be detected through uneven shoulders or hips that could vary in the angle. The COBB's angle is noticeable when a patient bends forward. If there's an inclination, that is a positive side of scoliosis. Our solution: by using the free library OpenCV for artificial vision, we were able to detect traces in images. This started by detecting the lines of a drawing, and we went on and adapted it to detect the silhouette of a subject's back. Once we have the much more simple layout of our subject's back, we can easily identify the COBB angle and therefore identify the presence of scoliosis in set cases using the research data that has been further developed through many years of experience.
Hi everyone, in this video I want to show you how our GUI works. Okay, let's start. Now we come to our interface. You can see the name here, Self-Screening System for Scoliosis. Firstly, we input our username, like test. And here we upload our user profile picture. And in this area, here's some tips for taking the pictures. If you follow the tips to take the picture, you can get a picture that can be processed better. And we click the start button to upload the picture. Okay, that's our main interface. Welcome test. Please follow the example images to draw two lines on the shoulders and waist of your picture. Here's the example images before and after, and here's the picture after processing. Now we draw two lines. Now you can see two angles of each line, and also the most important thing, the COBB angle. Now the COBB angle is under 10 degrees, so we come to the first result. Congratulations, your spine looks very healthy. And when you click the right mouse button, you can have another opportunity to draw the two lines. Now the COBB angle is between 10 and 20 degrees, so we consider you as having a mild scoliosis. And here's also some corresponding suggestions. Now the COBB angle is more than 20 degrees, so it's our third case. You seem to have scoliosis. The last thing is when you click this button, you can know more about how the result came out because we put our Google Drive link here. Okay, that's all about our GUI part. Thank you for your listening.
This is the introduction video of our extension function. Let's get started. A short recap. Our main goal of this project is to use an image in the bent forward position to estimate whether the test subject has scoliosis. We want to extend our program to assess whether the posture is good enough for our prediction. Our idea is to take a video as an input and have real-time feedback on whether the current pose is good enough. Our core function uses the thoracic COBB angle as a criterion to estimate whether the test subject has scoliosis or not. The current version of calculating the angle is to draw a contour of the posture and to use the mouse to take the position of 4 points from the back and calculate the angle from these 4 points. A real-time estimation is now not available in the current phase. We provide substitutions of two alternative extension functions. The idea of the first variant is only calculating the thoracic COBB angle in a static way. We first extract frames from the video and save them as images. The extraction rate is 1 frame per second. We next present the frame individually and ask the user to select the points by themselves. Here is a short example. After choosing the points in each frame, the user needs to click on any button on the keyboard to have the next frame. After all the frames are processed, we provide an average thoracic COBB angle back to the users in the console line. An average result is more robust than having only one estimation. The second version is to draw a contour in real time in case we have a better idea of our core function that can calculate the angle automatically. This is an example. Thank you for taking a look at this video. Hope you guys have fun with our video.